Hello, testing, testing. Hello, hello. Okay, I think my mic is working. I should be popping in any moment now. Bam. Hello. Good morning, or afternoon, or evening, wherever you are. We're trying more Facebook/Meta questions today, but today is review week because we have so many questions to review. I want to try all the questions that, gave me a hard time in the past 2 weeks. Okay, let's so whenever I get a question wrong or, it gives me a hard time, I write it down and I star it. If it gives me a really, really hard time, I'm going to try the starred ones first. So the first one I have written down is Leetcode 162. Code 162. Find peak element. Oh, I think I kind of remember this one. Excuse me. A peak element is an element that is strictly greater than its neighbors. Okay? Given a zero-indexed integer nums, find a peak element and return its index. If the array contains multiple peaks, return the index to any of the peaks. You may imagine that nums minus 1 equals nums n equals negative infinity. In other words, an element is always considered to be strictly greater than the neighbor that is outside the array. Okay. You must write an algorithm that runs in O log n time. Okay. I kind of remember this. Okay. So here the peak is 0, 1, 2, index 2. Here you can either return index number 1. Just the one says, saw you randomly on my recommended low. You interviewing soon? Yeah, I am. I've been Leetcoding for the past 35 days, I think, give or take. Yeah, I'm not good at interviews and Leetcoding. I'm preparing hard. Hopefully the efforts pay off. But yeah, welcome to the stream, Just the One. How are you doing today? Okay, your function can return either index number 1, where the peak element is 2, or index number 5, where the peak element is 6. Okay, I think I remember how to do this. O log n time is a big clue, right? It's like binary search. Let's see. And you cut your range depending on whether the middle element is like on a increasing range or a decreasing range, right? Okay. So if my middle element is on an increasing range, that means the peak could be on my right. Yeah. And it doesn't matter if I just increase till the end too, because the end is negative infinity, right? That just means my last element. Yeah, my last element is the answer. If I'm on a descending range, then my peak is still left. Yeah, okay. That makes sense. So let's start with the binary search int. Well, yeah, binary search. My left pointer is equal to 0. Int right pointer is equal to nums.length minus 1, aka the last element. Okay, so while, classic binary search left is less than the right, because I guess if left is equal to the right, then that's probably the answer. Let's calculate what m is. Int m is equal to left plus right divided by 2. Okay, the value of val m is equal to, so if m is, what if it's out of bounds? Is it possible to be out of bounds? Wait, it can't, right? Because we're always just increasing our left, increasing our right. It can't be out of bounds. Okay. So it's safe to just say nums m like this. But to check if we're on a descending or ascending slope, we have to check our next. So int val next is equal to, yeah, okay. So if m plus 1, yeah, because we could go out of bounds to the right, is greater than nums length is greater than or equal to. Because the last index is nums dot length minus 1. Yeah, okay. Then you return negative infinity math dot integer dot min value. Let me decrease the string size. Hopefully y'all can still read that. Or you return the actual value nums m plus 1. Okay. I have no idea if this is right or not. So if val m is less than val next, meaning I'm on a ascending slope, then my peak is to my right. Yeah, my peak is to my right. So left is equal to m plus 1. Yeah. Else, so let me just comment to make this clear. This is on ascending. This is descending. Then your right is equal to m. Okay. Let me see. Does this make sense? M. Alright then, and then you return one of these, right? Right. I have no idea why I'm doing a plus 1 here, by the way. I'm just following my usual intuition of binary search. Okay, let's run this thing. Probably not gonna work, but it's okay, we can debug it. Compile error. Greater than or equal to. Okay. Wow. Look at that, boys. It worked. Cool. Wow. Jesus. Alright, it worked. Does it work if I remove the m, the plus 1 here? I'm actually just adding the 1 purely from intuition from my usual binary search algorithms. Time limit exceeded. Whoa, why would time limit exceed though? Wait, that's actually so interesting. Why would time limit exceed here? System.out.println m. My intuition was like right for some reason. I don't know why. Oh, let's print out what m is. Well, let's print out the left plus space plus m plus right. I actually have no idea why. This will be an infinite loop. Okay, so it's stuck on 1, 1, and 2 forever. Ah, I see. So the middle, 1 plus 2 divided by 3. What do you mean is that? 0, 1, 2. So it's stuck here. So m is 2. So it's on an ascending slope. It wants to go to the right, right? Okay. Yeah, we don't narrow our range down at all. M plus 1. Val m is less than val done. Val next. What happens if it's like here though? The right is less than... If it's like... I don't know, 0, 2, 0, 1. 1 divided by 2 is 0. Okay, so it's here. M is just 3. Oh, okay. Okay. I don't understand the intuition still, but I see why it's needed. Okay. Let me mark this problem as done then. 162. Next up is question 740. Leetcode 740. Delete and earn. You are given an integer array nums. You want to maximize the number of points you get by performing the following operation any number of times. Pick any nums I and delete it to earn nums I points. Okay. Afterwards, you must delete every element equal to nums I minus 1 and every element equal to nums I plus 1. Return the maximum number of points you can earn by applying the above operations some number of times. Okay. Delete 4 to earn 2 points. 3 is also deleted. Nums equals 2. Delete 2 to earn 2 points. Okay. Delete a 3 to earn 3 points. A3. All 2s and 4s are also deleted. Nums equals 3, 3. Delete a 3 again. Okay. I see. I think I remember this one too. Every time you delete a number, might as well delete everything in that number, right? Yeah. This is like house robbers. Except you gotta pre-compute some stuff. Kind of like each group of the same number is a house. So we gotta figure out the sum of all the numbers. By the way, is this sorted? No, it's not sorted. We have to figure that out ourselves. Yeah, this is not sorted for sure. So we have to figure out the max number of points we can get from each number by deleting every instance of that number. How do we do this? Do we put this in a hash map? Yeah, possibly hash map. We probably just need to do some recursion stuff where... Yeah, okay. Every time, we probably start at... Yeah, we can do the use me, no use me method. You can start at house 1 and be like, okay, can I use me? Yeah. Can I use me? Oh. And the important thing is that every element equal to, this is the value, nums I minus 1. So even if it doesn't exist, yeah, okay, I see. We can start at house number 1 and be like, okay, do I use me or don't use me? If I use me, then add my value and recurse, but start 2 houses down. Yeah, okay. And then the hash map can default to 0. Okay, I see how to do this. Step 1, calculate. total sum of each number total occurrences of each number, okay. Or int I for int num in nums so what's the range of this thing? All right. Okay, we need a hash map tracking everything. Hash map integer is equal to counts. Counts is equal to new hash map. Okay, so the key is equal to the num, value is equal to num occurrences. So we can conveniently, whenever we use a number, we use all of it. Just take all of them out completely. Okay. Int current count of the current number is equal to counts dot get or default. Plug in the number as a key, 0 by default. We increment it by 1 plus plus and we put it back in. Counts dot put the num with current count. We should also keep track of, since we're starting from the first house to the last house, we should probably keep track of, well, where the first house begins, no? It's guaranteed to be 1 to 10 to the 4. Let's do int min value, int max value. That's our range that we need to start recursing on later. 10 to the 4 isn't that big, right? 10,000? Okay. Actually, we can just start at 1, right? Yeah. Let's just do a max value right now. Max value is equal to, by default, integer dot min value. Max value is equal to map dot max, the current max value, with current count, with the current number. Okay, it's time to start recursing. What do we do in our recursive function? Nums, maybe our current index or number. Current number. What else do we need? Max value. Max value. Sure, let's start with that for now. What are our base cases? So if I'm out of bounds, if the current number is less than, well, greater than the max value, then we're out of bounds. Return 0. Else you start recursing, so remember the use me no use me strategy. What happens if I use the current number that we're on? We need to delete all the numbers and add all of its values. Oh boy, so we need the cache too of the counts. Man, this is so many. Wait, Java variable scope. Can I still access that map inside the helper function? Can inner functions access outer function variables? Can access variables from the outer function including scope as long as the outer variable is effectively final. Effectively final variable. It is not changed after initialization. Oh. That might be a deal breaker for me. It is treated as a final variable. Okay, I'll pass it into the parameters to be safe. Oh, wrong problem. Okay, what happens if I use the current number? Well, we need to calculate my value first. The value of using all my numbers, the current number. Int my value is equal to the current number times all the counts of me dot get or default the current number default 0. So the value of use me is equal to my value plus recurse delete and earn the nums, the current number plus 2, because I can't use the consecutive one next to me again now. You can't rob consecutively. I'm trying to think, what will happen to n-1? That should be already handled, right? If you can't rob consecutive houses. Yeah, that should already be handled. Current num plus 2. The max value should be the same. And passing the same counts as well. Alright. No use me int no use me is equal to, why is this an equal sign? This is supposed to be a plus sign. So don't add my value and earn nums. You can use the current num plus 1. Max val counts. Okay, and then you find the best solution of use me and no use me. Math dot int result is equal to math dot max use me no use me, and then you return the result. And I can't forget to actually call the recursive function here. Return delete and earn the nums. The current num will start with 0 all the way up to, the max. Current num. Wait, max value is max value and counts, you just pass it in. Alright, let's see how many compilation errors we have. Line 15. Is it counts? Yeah, counts. Wow. Well, that's pretty crazy. We got it. Wow. Second try, baby. My prediction is if we submit it now, we'll get time limit exceeded. We need to do some caching, I expect. Submit the thing. Yeah, time limit exceeded. Time to do some caching. Yay. How do we cache this, by the way? 0 to the max value, right? We can totally cache based on the max value. Wait, no, or the current number. The current number. Yeah, okay. We can do like a int cache is equal to new int max value plus 1. So it's from 0 to max value, the indices. Okay. We input that here. Cache. Oh my goodness, so many variables. Int cache. Okay, so one more base case is if... Wait, what's the default value for ints? It's 0, isn't it? Let's instantiate everything to -1, then arrays.fill cache with -1. So if we have a cache hit, aka the cache with the current number is not equal to -1, then you return the cache value. Okay, the result, we cache the result too. Cache current number is equal to result. Yay. Let's run this thing. No. Oh, we've got to put the cache in too. Oh, again, forgot to update the cache here. Cache. Hey, let's go. I want to run, use test case. Fantastic. Submit that thing. Let's go. That's awesome. I'm currently reviewing the most recently starred ones. So I'll probably remember less and less as we go on. This was 740. 740. Should we do another one? Should we do an easyware one? 1762? Sure, 1762. Leetcode 1762. Buildings with ocean view. This is a premium question. Oh, okay. Time to log into my brother's account. Leetcode 1762, 1762. Bam. Shoot, wrong link. Leetcode problems. Hold on, I need to go to a specific page for it to load. Does not want to load. Okay. Give me a sec. There we go. This is a premium problem, so I opened my brother's account because he is premium. Let's reset the answer here, confirm. There are n buildings in a line. You are given an integer array heights of size n that represents the heights of the buildings in the line. The ocean is to the right of the buildings. A building has an ocean view if the building can see the ocean without obstructions. Formally, a building has an ocean view if all the buildings to its right have a smaller height. Return a list of indices of buildings that have an ocean view, sorted in increasing order. Okay. In increasing order, okay. Output is 0, 2, 3. Building 1, 0 index does not have Gisa John. How do you pronounce the name? Is it Gisa or Gisa John? You, hello. Are you live? Yeah, I'm live. Hello, AM creation. Or is it difference M creation, triangle M creation? Yeah, hello, welcome to the stream. Return a list of indices of buildings that have an ocean view sorted in increasing order. How do we tell if it's an ocean view? If it's the max of, well, we can go from right to left, right? If it's the max, yeah, we can go from right to left and track the current max, I guess. Yeah. If my building is indeed the current max, then it should have a view, and then we can, compile them in order at first into an array list and then reverse the array list. I think that's a strategy. Gisa John says, are we practicing for an interview? Yeah, we are. I'm recently interviewing for software engineering positions. It's hard. I'm not that good at Leetcoding. So I am here, Leetcoding my butt off. Hopefully I can pass some interviews and get a job, Are you guys software engineers too? Surely if you're tuning into a Leetcoding stream, you have some notion of what Leetcoding is, Find buildings. Okay. I think what I'm gonna do right now is make a list of the resulting buildings and then reverse it at the end. Yeah, okay. List. Integer. Do result is equal to new array list. Okay, and then for our buildings, we need to track our local max. Oh, you just started your CS major. Oh, that's pretty sick. Good luck, good luck. I actually recently battled a senior CS major in a coding battle. Very nearly got my butt kicked. I'm doing web dev. Oh, that's pretty sick. What stack do people use recently? Yeah, what tools do you use? Like React? I don't know, Node.js? Are you front-end, back-end? That's pretty cool. Is equal to integer.min value by default, I suppose. Let me make this bigger so it's easier to see. Okay, so we start from right to left. So int, let's do b for building is equal to heights.length minus 1, while b is greater than or equal to 0. B minus minus. Okay. So if the current building is greater than the local max, that means it has a view. and you add it to result. Result.add b. Nice. And then you update the local max no matter what. Local max is equal to math.max of the current local max and the current building height. Okay. Let's do a sanity check right now, okay? Let's do system.out.println and just print out what our resulting array lists are. Jesus says, it's the intro class to CS, but the goal is to make it into software engineering. Oh, okay, it's just the intro class. Yeah, good luck on classes, man. This sounds pretty exciting. Brand new CS major. Let's go. What got you into CS? I know people get into CS for all sorts of reasons because CS has so many ROMs and so many subjects in it. Let's return null by default just to fulfill, our return type. I just want to do a sanity check, print out what our result is right now before I convert it to an array. Okay, wrong answer. That is not right. Expected 0, 2, 3, 0, 0, 1, 2, and then 3. Wait, yeah. What happened to this? Oh, I'm comparing the indices, not the actual value. No, I know where I went wrong. Int actual height. Let's see, my height is equal to height of the building. Okay. So instead of comparing the indices, I compare my height. Local max height is equal to local max compared to my height. Nice. So now I have 320, 320, very nice. 3210, 3210. Okay, so I got the answer, but it's just backwards. 33. I have no idea how to compare all this. Ambuj Haku says, great, keep it up. Thanks, man. I appreciate the encouragement. Okay, so I got the answer. All I have to do is reverse it into a int array then. Very nice, okay. Let's make an int array for our answer. Let's say result to an array, a is for array, is equal to new int with the same length as our result dot size. Okay, so then we need to reverse our result into this. For int I is equal to result size minus 1, that's the rightmost index. I is greater than or equal to 0, I minus minus. Jesus says, I don't know, I ain't going to lie, I low-key love tech, plus let's be honest, coding looks hella cool. Yeah, coding does look pretty cool in movies, huh? When, at least I think that's what you're talking about. Or for me, that's where coding looks the coolest. It's kind of unrealistic sometimes, but it's just kind of fun to see hackers in movies like typing like crazy and all sorts of consoles and whatever appear on the screen. Like, we're in. We hacked into the mainframe. I don't think that's accurate at all. It's very cool to see anyways. Tech is very cool though. Yeah, they come up with all sorts of weird... Well, I think it's mostly hardware, no? They never get a bug either. Yeah, it's all just flawless code from the beginning. That is totally realistic. Okay. What do I do from here? I think I want an integer to track int. This is so jank. The index on my result A index is equal to 0. Alright. Result A and the A index, you know, the index specifically pointing to this is equal to result dot get I, and then I need to update result A index. I need to increment it at the end to plus plus, and then I need to return result array. Let's run this thing. Hey, let's go. I think we did it, boys. Yeah, it's all accepted. The moment of truth is we need to submit this now. Jesus says, anyways, what college you go to? Are you self-taught? Hey, let's go. We did it. Hey. Jesus says, anyways, what college you go to? Are you self-taught? Oh, I already graduated. I'm not attending college anymore. Coldfist says, hi. How are you? I'm good. How are you? I got some decent sleep yesterday. Jesus says www. It would be even more W if I had a job, you know? Which is why I'm doing this. I absolutely am not great at Leetcoding in interviews. Sleep, I don't have it. You know, what are you doing? Oh, I'm solving Leetcode problems. This problem is called building with an ocean view. You're given a list of building heights, and you have to figure out which buildings have an ocean view, like a clear line of sight to the ocean. Yeah, that's basically the problem. Yeah. By the way, speaking of sleep, have you guys heard of this new game called Pokemon Sleep? It's like a new version of Pokemon. It's been on my YouTube ads for a while now, so I decided to try it. You basically catch Pokemon while you sleep. It's like pretty goofy. Jesus says, is it actually hard, the tech interviews? For me it is, yeah. What happens is, well, I can tell you about interviews. Deep says, hi. Hello. Hi, Deep. I can tell you what interviews are like. So usually in American interviews, there's multiple rounds. In the first round, they usually give you like a Leetcode problem, like this. That's what I'm practicing here. They usually give you like an easy to medium problem in the beginning. In the second round, they give you another Leetcode problem. And it gets progressively harder and harder, the problems that they give you. Maybe there's a third interview. Some companies go on to on-site interviews afterwards, where they test you on, you know, more Leetcode questions. and then they give you, on the on-site interviews, they give you a behavioral interview too. They ask you about your prior experiences, you know, how do you interact with coworkers? And then they give you a system design question where they ask you to draw out the architecture of an app from scratch, which is hard too. I need to study that too. Yeah, it's hard. I'm currently interviewing right now. I would say my pass rate for before I started streaming, my pass rate for the first rounds, like less than 50%, is pretty bad. But I think I got my first round pass rate to above or at 50% now. Just better. Second rounds are still kind of getting me, because you know the problems get progressively harder. Kunha says, do you have a background in software engineering, or did you just get into it recently? Well, I did say I graduated, right? How many rounds will there be? Honestly, it depends on the company. The shortest one I've had so far was Two coding interviews, two Leetcode, like, how do I say this? Two Leetcode rounds plus a onsite. The onsite, they test you on behavioral and system design. Yeah. Wait, let me look at my calendar. I literally have a calendar right here. Oh my goodness. Okay, the big boy companies have a lot of rounds sometimes. Yeah, I'm looking at my calendar. There's this big boy company that I'm interviewing for right now. There's two Leetcoding interviews that I've passed so far. Oh my goodness, there's a on-site interview on Friday. Oh no. There's another interview on the 14th and the 16th for the same company. So like 5 rounds total. Holy Jesus. Yeah, 2 of those are probably more Leetcode, and one of them is either behavioral or system design. What about my background? Well, I don't want to get too deep into my work history, so I'm probably going to pass on that question. Sorry about that. What year do you actually start learning problems like this? Oh, you're in college now, right? Well, I don't know the curriculum for all colleges, but in my college, we started learning like Leetcode stuff at around year 2, I think. Yeah. Well, again, it depends on your college. In my college, we had a Java course. Well, yeah, that's what I'm using right now, Java. And the exam questions are pretty Leetcodey sometimes. Yeah. I don't know. I actually have not taken a system design course in college. I don't know if I just happened to not take it or they actually don't teach it. Well, I probably just didn't take the class. But yeah, I'm studying system design through the Alex Shu book right now. Cut faces. I gotta go, sorry, Sia. No worries, thanks for dropping by, I appreciate. Jesus says, how hard was it coming HTML into Java? Well, I didn't start with HTML actually. Java was my first language. I do know some HTML though. I would say Java is harder than HTML. There's a lot more features to it. I don't see how you would implement any of this in HTML, to be honest. But in web development, I think you learn JavaScript, right? You can do all of this in JavaScript. Yeah. I don't think there's even a Deep AKSP24 says, will you be doing Leetcode regularly? Oh yeah. I've been Leetcoding. I've been streaming myself Leetcoding almost every day for like a month now. Yeah. I don't stream on Sundays though. Yeah. Sometimes I take a break here and there, but it's nearly every day. Yeah. I feel like I improved a lot though. If you look at my earlier streams, like right now I've done 3 problems in an hour, right? That's considered like an okay pace. If you look at my earlier streams, I spent like an hour, more than an hour doing an easy problem. It's pretty bad. That's why I haven't been passing any interviews in the beginning. But yeah, hey guys, I also do like coding battles. I compete with Leetcode. Another thing that I've been doing besides like just streaming on my own is wait, Chet's spinny eyes. Shameless self-promo here. Whoop. There we go. There's me, I'm live now. I've also been challenging because, you know, one of my biggest, I don't know, negative traits is that I get way too nervous under pressure when coding. So I'm doing Leetcode like 1 per day. That's pretty good too, to be honest. I do, yeah. At least you're consistent per day, right? That's pretty good. I'm also doing coding battles, by the way. Last week I challenged a real CS major to a coding battle. Like we just 4 random Leetcode questions. were generated. Whoever does the most in 60 minutes wins. 2 weeks ago, I challenged a real database engineer to a coding battle. And then 3 weeks ago, I challenged a real software engineer to a Leetcode battle. It was pretty fun. If you want to see me like actually be nervous and code, that's where you watch it. Jesus says, wait, doesn't software engineering mean you're full stack? Not necessarily. There's like front-end software engineering, there's back-end software engineering. Yeah, front-end is like UI, back-end is like the server, what the server actually does behind the UI. Yeah. Yeah, hey Jisa, what realm of software engineering are you interested in? Like, is there a particular field you want to go into? Full stack comes under software engineering, right? What am I doing? I'm targeting back-end software engineering because that's what I have the most experience in, I guess. Yeah. It is 10 o'clock, which means it is system design study time. I'm moving away from Leetcoding now. So I'm probably going to be more silent from now on because I'm just going to be taking notes. Jesus says I want to be back-end. Is this just because I said I'm doing back-end? That's funny. No, you should explore, man, and see what you like. Yeah, there's lots of realms of computer engineering, computer science. Jesus says, I don't like front end because of CSS. Oh, yeah, CSS is pretty annoying sometimes, right? The meme of how to center a div. The styling really is not my thing. Well, yeah, I agree. It feels like you're doing a lot of stuff, but for very little reward or output. It feels like a lot of trial and error too. Yeah, it feels like HTML you're actually doing something practical, right? Like, okay, I type this, I don't know, header here, something actually appears. I type this form box, something actually appears. Or CSS is like, I don't know, yeah, you add a lot, but there's very little output. Kunha says, do you think that everyone who finished a degree in computer science, let's say, is good at programming? Oh, that's hard to say. Like, no. No. I wasn't good at programming. At least in terms of like preparing for coding interviews. You have to Leetcode. Unless, I don't know, the interview format changes in the future. Kanha says, I have one and I feel super mid compared to others and I have this constant need to just improve. I feel that. Are you like in a really competitive school? Like everybody's just really smart? So then even though you were the top of your class in high school, it feels like you're just mid compared to here? Deep says, I recently graduated. Here I am without a job. Oh. Well, we're in the same boat. The part about being unemployed, I mean. Jesus says, oh, okay. Jesus says, what do you think you need to land an intern? Oh. Honestly, I'm not the best person to ask that question. I landed an intern before, but that was what, many years ago, so this advice may be outdated, but do projects. Do interesting personal projects and put them on your resume. I think companies like that. Yeah. I don't know. You might need to do some Googling for that. I'm not the best person. But when I was applying for internships, yeah, put all your interesting projects, your best projects onto a resume. Do projects that hopefully few other people are doing. Can you give any project idea backend? Why are people asking for CS advice? I'm not the best person for that. Can you give any project idea backend? Man, I really don't know, man. Funny backend projects. Wait, backend projects for internships. I'm not a robot. Just your perspective. I mean, backend, huh? My God, people are straight up redesigning Shopify. Backend projects to put on resume. Okay, here. Build a finance, create a text analyzer, build a proxy server, image manipulation application. On internship resume. Backend projects for resumes. Web APIs. Oh, okay. I really don't know. Backend projects idea, create developer portfolio. User authentication, landing page. People often do like their own, like a about me webpage that showcases your other stuff or just introduces yourself. So instead of using Wix or whatnot, finance application, text analyzer, to-do app. Oh, I have a friend who built this thing, a to-do app. Try that maybe? I have a friend who built one and he landed a job. Yeah, like a planner, scheduler, to-do app, that kind of deal. Yeah, maybe try that. It's like a practical app too. Yeah. Maybe you can even use it yourself if you're done with it. Yeah. Good exercise. Jesus says, I was looking around, but I don't think there's internship for languages like HTML and CSS. Is there? So HTML, CSS is front-end roles, right? Front-end internships. Oh, look. Am I job searching for you guys now? Qualifications, pursuing an undergraduate or master's degree in software development. Experience with one of the coding. Experience with HTML, CSS, and JavaScript. Able to work on site. Okay. You want to work at TikTok? TikTok is having some weird stuff going on with the government right now, but you can still join, have the internship, and then leave before they crash, you know? Yeah, I have no idea where you are, but this looks like it's in San Jose. Oh, it's all Bay Area stuff. Interesting. Yeah, you want to work at TikTok, Jisa? HTML, CSS. I'm not in CS. Wait, you're not in CS? I'm in Seattle. Oh, Seattle. Oh, look. ByteDance is TikTok, right? JavaScript, HTML, CSS. Basically the same job. ByteDance is parent company of TikTok. ByteDance. Well, there you go. Apply to that. Reddit? Senior. Oh, that's senior. Front-end engineer intern. Yeah, this looks like it's for you. No? The type of front-end internships, Seattle. Okay, I really need to study system design now. Yeah, it's a parent company of TikTok. Yeah, if you land this job, you'll be able to say that you work for a giant social media company, which looks good on your resume, I guess. Really? There's only 3 jobs in your area? Crazy. Okay, let's study system design now. What do you guys want to learn? Jesus says thank you. No worries. Were you unable to search for it because you don't know what search terms to use? Like, were you just searching for... But if you don't mind me asking, how do you study? I Leetcode every day, and I read system design. In the morning. Oh, like tech? I don't really study tech. What's the book name? Oh. Alex Shu. What? This is the book. System Design Interview and Insider's Guide by Alex Shu. Yeah. How do you study tech? I don't think I'm the best person to ask for that too. I'm actually just currently learning like basic front-end web development, like HTML, CSS, JavaScript, React. I'm using freecodecamp.org. Freecodecamp.org. Yeah. They have some web dev courses. Oh, you have to log in. Yeah. I'm not sure if it's the best resource though. Wait, which company am I interviewing for today? Banking app? Newsfeed system, chat system? How do you get better at coding is really the question. Well, Leetcode specific? Just Leetcode every day? How do you get better at coding in general? Projects? Whether it's your own personal projects or, experience on the job. Yeah, I would say personal projects. Try building something. But, that's easier said than done. Unique ID generator in distribute system. I'm trying to decide what to study. I'm interviewing for a banking app today. Let's go URL shortener. Wait, actually, let me do some research first. Okay, design a system where you can submit a check by taking a photo from your phone. I was grilled at. How would you ensure that funds will be deposited once the check is cleared? Oh my god. Okay, like payment processing then. Okay. That's the type of question I need to look at. Are there any things along that line? Design a newsfeed system, a chat system? I can't decide. Newsfeed system, chat system. Design YouTube. Oh my goodness. Okay. Oh, I don't know. Chat system. Google Drive. How long is this? Do I have time to do this? High-level design. Oh my goodness. I probably don't have time to do this today. Let's do URL shortener. Sure, URL shortener. Design a URL shortening device like tinyURL. What's web crawler? Oh, it's like a piece of software that reads lots of web pages. Yeah. Can we see some of your projects? The projects are not impressive at all. Maybe later. Maybe in some other stream. Wait. Also, I just realized I probably can't show you my project without doxing myself. That's an issue too. I'll have to think about it. But my projects are actually not that impressive. Okay. I will come back to ask. Alright. Can you give an example of how a URL shortener will work? Assume URL. This is the original URL. Your service creates an alias with a shorter length. This. If you click the alias, it redirects you to the original URL. What is the traffic volume? 100 million URLs generated per day. How long is a shortened URL? As short as possible. What characters are allowed? Yeah, just heads up. I'll probably be more silent from now on because I'm just reading and taking notes. I'm usually more talkative during Leetcoding sessions. Shortened URL can be a combination of numbers. Can shortened URL be deleted or updated? Okay, it cannot be deleted or updated. Given a shorter URL, redirect to the original URL. So we have URL shortening and URL redirecting. 100 million URLs generated per day. 100 million divided by 24. Okay. Okay, assuming read to write is 10 to 1, read operation per second is this. Okay, because this times 10. Assume it will run for 10 years. This means we must support 100 million, 365 billion records. Okay, 100 million times number of days in a year. Assume URL length is 100. 100 bytes times 10 years times Okay. Where did this come from? Is it? Isn't this already for 10 years? Alright. Gunter says, it crawls the web and tickles your toes. Propose high-level design and get buy-in. Okay. We will design the API's REST style. To create a new URL, a client sends a post request which contains one parameter, the original long URL. Okay, post API v1 data shorten. Okay, URL redirecting. To redirect a short URL to the corresponding URL, a client sends a GET request. The API looks like this. GET API v1 short URL. Return long URL for HTTP redirection. Okay. Shows what happens when you enter a tiny URL onto the browser. Once the server receives a tiny URL request, it changes the short URL to the long URL with a 301 redirect. So it's on the server side. Okay, so the client visits the short URL, which is the tiny URL server, and it redirects you to the long URL. Wait, so it returns the long URL to the client, and then the client visits the actual Amazon server. Okay. Do browsers just by default redirect when they get a 301? Status code 301 redirect. Oh, okay. When a browser receives a 301 code, it automatically redirects the user to a new URL. Okay, that makes sense. I should probably write that down. That sounds really important. What chapter are we on, by the way? Chapter 5, chapter 8. 10, 9, 8. Okay. Okay, so some important things to note. If a server sends a status code 301, your browser is programmed to automatically redirect to the returned URL. Okay, so that's how redirects work. Okay. 301 redirect shows that the requested URL is permanently moved. Okay. 302 redirect. Can I make this even bigger? Nice. Means that the URL is temporarily moved to the long URL. If the priority is to reduce the server load, this is too big. Using 301 redirect makes sense as only the first request of the same URL is sent to URL shortening servers. However, if analytics is important, 302 redirect is a better choice as it can track click rate and source of the click more easily. Okay. The most intuitive way to implement URL redirecting is to use hash tables. Assuming the hash table stores the, short URL is a key, long URL is the value, get long URL, hash table.get short URL. Once you get the long URL, perform the URL redirect. Okay, that's fine. Let's assume the short URL looks like this, tinyurl.com/hash value. To support the URL shortening use case, we must find a hash function that maps a long URL to the hash value as shown. Yeah, wait, how do we do this? The hash function must satisfy the following requirements. Each long URL must be hashed to one hash value. Each hash value must be mapped to the long URL. Detailed design for the hash function will be discussed in the deep dive. Okay, a design deep dive. Data model. Everything is stored in a hash table. A better option is to store short and long mapping in a relational database. The simplified version of the table contains, so ID, short URL, long URL, Memory resources are limited and expensive, Hash function is used to hash a long URL to a short URL known as a hash value. Find the smallest n such that 62 to the power of n is greater than or equal to 365 billion. Oh, so that calculation was important. Okay, so we have 62 possible characters. Each character space has 62 possibilities, so 62 to the n, where n is our amount of characters. I see, so 62 to the power of what? Must be greater than 365 billion. I see. So we need 7 digits. Okay. We will explore 2 types of hash functions. The first one is hash plus collision resolution, and the second one is base 62 conversion. Let us look at them one by one. Okay, so here are some hash functions. We should implement a hash function that hashes a long URL to a 7-character string. Okay, SHA-1, I heard of that. SHA-1 is really long though. Shortest hash value from CRC32 is too long. How can I make it shorter? First approach is to collect the first 7 characters of a hash value, but it can lead to hash collisions, yes. We can recursively append a new predefined string until no more collision is discovered. We can recursively append a new predefined string until no more collision is discovered. Okay. Input is long URL, the hash function to convert it to a short URL. Does it exist in the DB? Yes, that means it is a collision. Long URL plus predefined string. But if it's predefined, doesn't that mean it'll be the same? Oh wait, no. No. I see. So let's say your shortened URL is like cat. Does it exist? So you cat plus whatever you defined. Cat black maybe. So it for sure doesn't exist in the DB because what was originally in the DB was just cat. It is expensive to query the database to check if a short URL exists for every request. Yeah. Base 62 conversion. Base conversion helps to convert the same number between its different number representation systems. Base 62 conversion is used as there are 62 possible characters for hash value. Let us use an example to explain how the conversion works. Convert this to 62. Velveteen says, hey chat. Oh, hey Velveteen. How's it going? I'm studying system design right now. It's a pretty quiet stream today. 0 to 0. Just woke up. Oh, sick. What time zone are you in? It's like 10:30 a.m. in my time zone too. I woke up about 1 hour 30 minutes ago. Yeah. In video says, yo, my head started rotating. Wait, really? Why? In video says, you must be pro. Nah, I'm barely understanding. 1:30 p.m. Dang, you woke up late. That's crazy. Okay. This is kind of confusing me now. Base 62 conversion. Mappings are 0 to 0, 9 to 9, 10 to A, 11 to B. Oh, I see. So we're using characters now to represent, because we can't write 36 out, right? Okay. In video says here it's 11 p.m. at night. Dang. So 2 times 62 to the power of 2, okay. Okay. Base 62. Nice. Okay. "62 possible characters for hash value." Wait, what are we converting to base 62 though? You are building something? No, I'm studying system design for an interview. Oh, I know. We're shortening a long URL based on 62 conversion. Wait, are we? Wait, what are we converting? NVIDIA says Google? No, I'm not good enough for Google. I appreciate you thinking I'm good enough for that though. Oh, fun fact. Really fun fact. I actually interviewed for Google before. A couple years ago. Did not pass. Did not pass at all. I think I got a timestamp problem in Leetcode. Did not know how to do it. Yeah. Okay, base 62 conversion. The short URL length is not fixed. It goes with the ID. Base 62 conversion is used in our design. Input long URL in DB. Yes, return the short URL. Else, generate a new ID. In video says, I'm new sub. Hey, welcome. Thank you for subbing. I appreciate. Convert ID to short URL. Okay, long URL is the input. The system checks if the long URL is in the database, right? So if it's already there, then we fetch it and return it to the client. If the long URL is new, a new unique ID primary key is generated by the unique ID generator. Does the primary key contain... Okay, well, I'm assuming the primary key contains... Wait, what? He didn't explain any of this. So I'm assuming this is like converted to a number, and then convert the ID to a short URL with base 62 conversion. Jesus says, all right, good luck. Thank you. Wait, hold on, I'm so confused. He didn't explain any of this. New unique ID, primary key is generated by the unique ID generator. Convert the ID to a short URL with base 62 conversion. Wait, we already have a unique ID though. Go do my own studies. Oh, good luck. Create a database row with ID, short URL, and long URL. Okay. To make the flow easier to understand, let us look at a concrete example. Long URL is this. Unique ID generator returns ID. Okay, so it's all numbers that we return. Isan Pandey says, can you please quickly explain what system design means? Oh, yeah. So in system design interviews, they're not asking you to code anything, usually. They're asking you to, given a app idea, map out what servers you would need and what, web components you need to design that service. Maybe I can pull up a picture or something. For example, let's say we're being asked to design a notification system, right? Meaning the company can call a API or like press a button or something, and then a notification pops up on your phone, or an SMS message pops on your phone, or you get an email. So how you would respond to that in an actual interview is with this drawing. You would need to identify like, okay, what servers do I need? What services do I need? So you'd be like, okay, so whenever we press the button or make the API call, we need to build beforehand a set of notification servers, and then it needs to point to this database, and these caches need to be in front of the database, and then we need all of these 4 cloud queues, and then we need these 4 clusters of servers to process these 4 cloud queues, and then each of these rows will map to a third-party API that handles the whatever communication format you want to support. For example, iOS or Apple devices have a special third-party service called Apple Push Notifications, APN. And then Android, SMS, and email has their own push services. Yeah. And then you would be like, okay, we need analytics for this too. And maybe rate limiting. Yeah, that's how you would respond in an interview. You can't just say that everything is done in one server, because that's too slow and it doesn't scale up well. Apparently the reason you do this is because we don't want one third-party API to just clog up our one server. If one server is handling all the requests, if say one third-party API is being really slow or it's down, then let's say I do like 4 calls, right? 1, 2, 3, 4. If this one is stuck, then everyone is stuck after me. So we want to parallelize our notification calls to third-party APIs. Yeah, they're basically going to ask you how to design an app and for it to be really fast and scale up really well. That's what I'm doing here, system design. They're not asking you to code anything. They're asking you to draw out or plan out a combination or, configuration of servers and services to make your app really fast. Basically to make the app, but in a really efficient way. It's basically it. And it's hard. It's really hard. Okay, back to the URL shortener. We're designing an app, by the way, to redirect short URLs into long URLs. Okay. Hey, Sean says, thank you. No problem. I was on the concrete example, right? Yeah, let's look at the concrete example. Assume the input long URL is this. Unique ID generator returns ID, which is a pure number, and then we convert it to a base 62. Visify says, what OS are you using? I'm not using any particular OS. I think you can make that decision later on. Yeah. Unless you're asking me what OS is my computer running on now, I'm using Windows. Wait, I feel like they never explained this unique ID generator. This option depends on the unique ID generator. Yeah, because you need everything to be a integer, right? Collision is impossible because ID is unique. Why don't we just straight up use what's generated by the unique ID generator though? I guess it's a lot shorter, right? Okay, sure. It could be a lot shorter. Do you write notes physically all the time? Most of the time, yeah. 90% of the time, yeah. I'm pretty old school. Two types of hash functions. Second one is base 62 conversion. Okay. I don't understand why we need this though. Why don't we just use the unique thing generated from our integer? Depends on unique ID generator. Visify says, what's your main programming language? It's Java. Okay, unique ID generator returns ID this. Why don't we just use this for the URL though? Convert ID. Velveteen says, I'm only used to seeing base 62 used as a cipher, so this is interesting. Yeah. I think they use 62 because that's the total number of characters you have. Yeah. Okay, so base 62 conversion, this turns into this. I guess it's shorter because you're using base 62. Save ID, short URL, long URL to database. Okay. Yeah, the distributed unique ID generator is worth mentioning. Well, yeah, you should have explained this before. Its primary function is to generate globally unique IDs, which are used for creating short URLs in a highly distributed environment. Implementing a unique ID generator is challenging. Oh great, so if I get this in an interview, I'm screwed. Luckily, we already have Discuss a few solutions in Chapter 7. Design a unique ID generator in distributed systems. Oh, this was in the previous chapter. Okay. URL redirecting deep dive. Okay, so the user makes a call to the load balancer to the web servers, cache database. Okay. A user clicks on a short URL. The load balancer forwards the request to web servers. If a short URL is already in the cache, return the long URL directly. If it's not in the cache, fetch the long URL from the database. Yes. If it's not in the database, it is likely a user entered an invalid short URL. Long URL is returned to the user. Okay. Okay. I assume we have a load balancer here because there's more reads than writes. We want it to be distributed. Yeah, okay. If there's extra time, here are a few additional talking points. Rate limiter. Malicious users can send overwhelming large number of URL shortening requests. Okay, yes, we read this last time. Web server scaling sets the web tier stateless. It is easy to scale the web tier by adding or removing web servers. True, we don't need to store user information. Database replication sharding are common techniques. Analytics. How many people click on the link? When do they click on the link? Availability, consistency, and reliability. We discussed in Chapter 1. Okay. Cool, we finished the chapter. Should I? So, the solution he went with highly depends on Chapter 7, design a unique ID generator. Should we read that? In a distributed sense? Design a unique ID generator in distributed systems. Should we save this for next time? Should we just skim this? Ishan says, would you consider this book a beginner's read but fundamentally strong? Yeah, I would say so. I'm definitely a beginner in system design. I haven't started reading until last week. Multi-master replication. The approach uses the database's auto-increment feature. Instead of increasing the next ID by 1, we increase it by k, where k is the number of database servers in use. What? Okay, UUID. Is UUID okay, so it contains characters too, that's not good. Ticket server, Twitter snowflake approach. Twitter's unique ID generation system is called Snowflake, is inspiring and can satisfy requirements. We divide an ID into different sections. Assign bit 1 bit will always be 0. Okay, timestamp 41 bits. Sure. Data center ID, machine ID, sequence number. For every ID generated on that machine/process, the sequence number is incremented by 1. The number is reset to 0 every millisecond. For every ID generated on that machine/process, the sequence number is incremented by 1. The number is reset to 0 every milliseconds. Won't we get some collisions here? 1 every millisecond. Oh wait. But the timestamp might make it unique. Yeah, okay. Yeah. Huh. Sequence number is incremented by 1. I see. So it's basically like which request number on a specific machine at a given time. That's pretty smart, yeah. So we can use this approach to generate a number for our 62-bit for our 62-bit design thing. So that's how we solve this. That's how we generate a unique ID for our 62-bit conversion thing. Okay. Hmm. 365 billion records. Okay, I think I understand the general gist of this. Man, how did they come up with the 62 bits thing though? Oh wait, the number of characters, right? In our hash. There are 62 possible characters for hash value. Mappings are here. Hash value consists of characters from 09 AZ consisting of this. Alright. I think I see it. We don't need to know this, right? We don't need to know n. Okay, I think I understand it. Shall we do like an exercise? Let's try covering this text up and try designing it ourselves. Right, can you guys see this? I'm gonna assume that you can. Okay. Okay, let's try. Sorry, I can't talk right now. I covered up the text. Let's try designing our tiny URL service ourselves. All from memory. Okay, so again, the basic idea is okay, let's talk about maybe creating the URL. So we have a client. Holy crap, I suck at writing on a tablet. We have a client. They query our servers. Okay, so what's the server gonna do? It's gonna query our database. What tablet do I use? It's a Huion. What's the model? Huion H610 Pro V2. Who misspelled Huion? Huion H610 Pro V2. Yeah. Okay. So it first queries our database. If it already contains, so this is the create URL. So if we already contain you know, the long URL, then we just return it. Then we just return the short one. By the way, this database will probably contain like an ID, the short URL, and then the long URL. In like a table format. Holy crow, this handwriting is atrocious. Okay, that's creating the URL. How do we get the URL? I mean, how do we redirect? So the client. Okay, so this is the server mapped to the short URL. What happens here? The client calls it. It's actually visiting it now. And this is the server, the original server. URL. What happens is the shorts this server will return a 301 status. And apparently how it works is most browsers interpret 301 as a auto redirect, so then it will automatically call the original server. This is 1, 2, this is 3. Yeah, that's really confusing to read. Holy crap, that's confusing as heck. Return short, else. And of course, else, if you don't contain the short URL, you create it, and then you put into the database under this. Okay, let's talk about the hash function. Okay, how do they derive the hash function again? We want to make it as short as possible, right? So we want to use as many possible characters as possible. So we're going to use what? 0 through 9, A through Z, and capital A through Z for simplicity, I guess. 0 through 9 is 9. How many letters are there in the alphabet? 26. 26 plus 26. Am I tripping? Is it 26 or 27? Letters in the alphabet. There's 26. Okay, I was right. So 26 plus 26. Oh no, it's math. 40 plus 12 is 52. Doing basic math here. Equals 61. Were we not using base 61? Wait, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, wait. I'm dumb. 0 through 9 is not 9, it's 10 characters. 1 through 9 is 9. Okay, we have 62 characters we can use. So what we do is we generate... Yeah, we have 62 characters, which is also our base right now. So what we do is we generate a random, I don't know, random integer ID. Unique number ID, which is the timestamp. We'll probably do, I don't know. Year plus month plus all the way up to the seconds. And then we'll add our data center. Our specific machine ID. And the request number. And this is reset to 0 every millisecond. Yeah, and then we just convert this to base 62, aka make it as short as possible, you know, from base 10 to 62, so it's you know, short as possible. And that's our tiny URL. So we can be like tiny URL slash, I don't know, 0 BC2 And that's what we store in here. Okay. Okay, let's compare our answer to the book. Let's see how far off we are. I feel like I wasn't that far off. We actually did not need to know what n is, right? For this, yeah. There's no collisions, yeah, because the unique ID. It's guaranteed to have no collisions. Yeah. Okay. Let's see, our client. Visit the short URL, status code, 301. Yes. And then visit the long URL. Nice, we got that. Hash function. 0 to 9, A to Z is 62 characters, yeah. Because you want to, I see. Yeah, I'm starting to see base 62 is to just reduce, is to shorten it as much as possible. Okay, we got the hash function right. URL redirecting deep dive, load balancer, web servers. Oh wait, we forgot the load balancer. We could stuff, yeah. Wait, get, return. Oh wait, there's another step for redirecting. Okay, load balancer could go here. To make it scale. Load balancer. And we have multiple servers here. Yeah, we could cache our DB too. We could put a cache in front of our database to make it faster. Otherwise, you know what? I think we got it. Otherwise, that's load balancer and cache is what we were missing. Did we visit the... Do we actually need one server for each tiny URL? That seems really inefficient. Once the server receives a tiny URL request, Velveteen says, that's pretty much how I remember the snowflake system being at least. Yeah, okay. Wait, I want to look up something. Well, URL shortening system design. Do you need one server for each shortened URL? No, you don't need one server with shortened URL. So that tiny URL is just mapped to like a cluster of servers. Web server. Okay, access the shortened URL, redirect to long. It's the same web server, huh? Okay, access the shortened URL, web servers. Alright, I guess these servers are the same. Alright. I guess if you want to visit it, yeah, okay. Maybe we have different APIs for visiting. That makes sense. Oh yeah, let's check on the Snowflake system too. Design. What's the Snowflake? Okay, here. Yes, from timestamp is timestamp data center ID, machine ID, sequence number. Oh, they converted the timestamp to 41 bits at timestamp to decimal plus Twitter epoch. Alright, I think this is good enough. I think I'm done for today. Thank you to everyone who came, study with me. Thank you, Valentine. Well, Velveteen, not Valentine. Velveteen. Thank you, Sean. Thanks, Visify. Thank you. See you guys tomorrow. Bye. Bye, Visify. See ya.